Hi friends, this video is on acceleration. Now what comes to your mind when I say the word acceleration? Are you thinking of a car or motorbike going really fast? But hold on, according to physics, acceleration does not mean going at a high speed. The word acceleration means change of speed, or more correctly, change of velocity. How do you accelerate a car? How do you change its velocity? Do you know there are three ways to accelerate a car? One way that you may already know is to press the accelerator. Now what are the other two ways to accelerate a car? Let me get in the car and show you how. The first way to accelerate a car is to use the accelerator. The accelerator pedal is down here. As the name suggests, it accelerates the car. So when you press the accelerator, the car goes faster and faster. The speed of the car increases. Remember, velocity is speed with direction. So speed is the value or the magnitude of the velocity. Now I'm going to start the car and drive, and I'll be pressing the accelerator, and you carefully observe the reading in the speedometer. As you can see, the speed at the start is 0. Ready? And as I keep the accelerator pressed, the speed of the car is increasing. What's the second way to accelerate the car? Remember, acceleration is change of velocity. Now change can be increase or decrease of speed. So how do you decrease the speed of a car? That's right, you press the brakes. So I'm going to drive and I'll be pressing the brakes, and you carefully observe the reading in the speedometer. Now can you see in the speedometer, the speed of the car is decreasing and it comes down to 0 when the car stops. So the brakes decrease the speed. Now you may feel that this is not acceleration, because typically we think acceleration means going faster and faster. But this is also a case of acceleration. It's known as retardation or negative acceleration. Now what is the third way to accelerate the car? We saw that accelerator increases the speed. The brakes decrease the speed. Now what's the third way to change the velocity? Let me give you a hint. Velocity is speed with direction. So the answer is to use the steering wheel to turn the car, change the direction of the car. If the car is going at a constant speed, let's say 5 meters per second, and you change the direction using the steering wheel, even in this case, the velocity is changing because the direction is changing. So the car is accelerating, and this is our third way to accelerate the car. I'm going to show you some more examples and you tell me whether there's acceleration or not and why. Remember, acceleration means change of velocity, and there are three ways to do it: increase the speed, decrease the speed, and change the direction. Let's take a look at the examples. Let's start with the first example. A car going at a constant speed and in a straight line. Dropping a pebble into water. Catching the ball. Throwing a ball up. A ball going around in a circle at a constant speed, like this. Are you ready with your answers? Let's take a look. Here the speed of the car is constant. And since the car is going in a straight line, the direction is also constant. Velocity is speed with direction. So the velocity of the car is constant. So what is the acceleration here? That's right. Acceleration is 0. Or we say that there is no acceleration here. When I drop the pebble, what is the initial speed? 0. As you can see from the splash, the pebble has a speed greater than 0 when it hits the water. Because of Earth's gravity, the speed of the pebble has increased. So this is an example of acceleration. When you're catching a ball, the ball has some speed. So before the catch, the initial speed is greater than 0. After the catch, the final speed of the ball is 0. So it's a case of retardation, since the speed of the ball decreased. When I throw the ball up, I give it some speed. So initial speed is greater than 0. The Earth's gravity is constantly pulling the ball down. So the speed of the ball is decreasing. At the highest point, the speed of the ball will be 0. So the ball going upwards is a case of retardation. When the ball comes down, its speed is increasing. So the ball is accelerating. In summary, the ball going up is retardation and the ball coming down is acceleration. Here the speed of the ball is constant. But is the velocity constant? No. Velocity is changing since the direction of the ball is constantly changing. Remember, acceleration is the rate of change of velocity. So this is an example of accelerated motion. Do you know what is this type of motion known as? That's right, uniform circular motion. We looked at different examples where there was acceleration, retardation, and no acceleration. We know acceleration is change of velocity, but how do you measure it? Acceleration is defined as the rate of change of velocity. Now, whenever you see this rate of, it means divided by time. So acceleration is change of velocity divided by time. Now let's use this definition to write the formula of acceleration. Let's say a body is moving with an initial velocity of u and it accelerates to a final velocity of v in, let's say, time t. So what is the formula of acceleration? A is equal to v minus u by t. Now let's use this formula to calculate acceleration in our car example. Let's say the car is initially at rest. So the initial velocity is 0 meter per second. Now I press the accelerator and it takes 5 seconds to reach the final velocity of 10 meter per second. So what's the acceleration? Let's use the formula v minus u by t. So that's 10 meter per second minus 0 meter per second by 5 seconds. So the acceleration is 2. But hold on, what are the units? So it's going to be meter per second by second. So the unit of acceleration is meter per second square. And the acceleration of the car is 2 meter per second square. Now, like velocity, acceleration is also a vector. So what is its direction? Since the acceleration is positive, it has the same direction as that of the velocity. Now the car is moving with a velocity of 10 meters per second and the brakes are applied. The car comes to a stop in, say, 10 seconds. So the initial velocity is 10 meter per second. The final velocity is 0 meter per second and the time here is 10 seconds. So what is the acceleration? Again, let's use the formula v minus u by t. So if you plug in the numbers, we get the acceleration as minus 1 meter per second square. The acceleration is negative because it's a case of decreasing velocity. And this is known as retardation. Now, what is the direction of this acceleration? That's right, it's opposite to the direction of the velocity because it's opposing the velocity. It's slowing the car down. Now a question is, if a body is under acceleration, is it in uniform motion or non-uniform motion? That's right, the correct answer is non-uniform motion. Because uniform motion means constant velocity. And when a body is accelerating, its velocity is changing. So an accelerating body is in non-uniform motion. Now let's talk about uniform and non-uniform acceleration. A falling ball is an example of an accelerated motion. But is this uniform acceleration or non-uniform acceleration? Let's analyze. Now the first question is, who is accelerating the ball? That's right, it's Earth's gravity. And that's why we call it acceleration due to gravity. Now at a particular place, the acceleration due to gravity is constant. Let's say here it's 9.8 meters per second square. Or I'm going to take it approximately as 10 meters per second square to make the calculations easy. So that means this ball is experiencing a constant acceleration of 10 meters per second square throughout its motion. So it doesn't matter whether it's here, here or here. Now let's closely analyze the motion of the ball. When I drop this ball, what is the initial velocity at the start? That's right, it's going to be 0. And the ball is continuously accelerating at a rate of 10 meters per second square downwards. So after 1 second, its velocity is going to be 10 meters per second. After 2 seconds, it's going to be 20 meters per second. And after 3 seconds, it will be 30 meters per second and so on. So can you see that the velocity is increasing at the rate of 10 meters per second every second? Because the acceleration is constant and it has a value of 10 meters per second square. So when the acceleration is constant, it's a case of uniform acceleration. So our falling ball example is a case of uniform acceleration. Now let's consider the example of a car that is accelerating. Is this a case of uniform acceleration or non-uniform acceleration? What do you think? Now let's imagine you're driving the car and the car is initially at rest. So the initial velocity is 0 meter per second. And now you press the accelerator. Let's say after 1 second, the velocity is 5 meter per second. And after 2 seconds, the velocity increases to 15 meter per second. And after 3 seconds, the velocity is 22 meters per second. So can you see that every 1 second, the increase in velocity is not the same? Because in a practical scenario, it's really hard to accelerate the car at a constant rate. We can calculate the value of acceleration every second. Let's use the formula A equal to V minus U by T. So in the first second, the acceleration is 5 meters per second square. In the second second, it's 10 meters per second square. And in the third second, it's 7 meters per second square. So can you see that the acceleration is changing over time? So this is a case of non-uniform acceleration. As we discussed in this video, acceleration is the rate of change of velocity. Now, what causes acceleration? For example, how do I accelerate this ball? I need to throw it with a force. So force causes acceleration. Other examples are force of the engine on a car, or Earth's gravity causes acceleration, or the force of the brakes cause retardation. But the topic of force will be done in a separate video. Now that we are done with the concept of acceleration, are you ready to take a look at the top 3 questions on this topic? Friends, try solving these questions and do post your answers and doubts by putting it in the comments below. I'm looking forward to reading your comments and I promise to reply to them as soon as possible. So I'm going to disappear and you pause the video here and give these questions a shot. And do remember to like, comment and share out this video and go hit the subscribe button for my channel right now. And you can also follow my Facebook page. Thanks for watching.